Ladies and gentlemen, let's observe that if they are two conductor wire, we put near to each other, and we notice that we use plastic ring. Plastic ring, the reason is let both of the conductor are free to move. Okay, if there is a repulsion force or there is attractive force, this means that the both rings WX and YZ, they will move either attract to approach to each other or away each other. Let's observe what happens when the current flow through the WX. What will happen if YZ also flow with current? So that means that now if the current are flow in the same direction, so we notice that they will attract each other. If one up and one down opposite direction, they repel each other. What will happen if I reverse the direction? So as a conclusion, we can say that if they are in the same direction, they will attract each other. Opposite direction, they repel each other. Same direction, attract. Opposite direction, repel to each other. Okay. Then consider when a current flows through a conductor, where we use the formula F equal to BIL sin delta. Okay, so we notice that B, the magnetic field produced, will be equal to mu naught current I. Okay, divide by 2 pi d. So now what happened? What happened? Yeah, just this one, just a single conductor only. If we have another conductor which we place near to the conductor just now, so what will be the F2? They will produce a force. Okay, the force produced is equal to B1, the magnetic field from the first one, times with the I2 times with the L, the length, over 2 pi d. Okay, so F2 will be equal to B1, yeah, the magnetic field produced, that means mu naught I1 over 2 pi d, okay, times with I2 L over 2 pi d. Okay, this means replace the Bi into it, so we get the force. Then if the B2, we consider the B2 is equal to mu naught I2 over 2 pi d. The F1 produced is because of I2, right? So mu naught I1 I2 L over 2 pi d, the F1 produced. Okay, F1 is equal to mu naught I1 I2 L over 2 pi d if they are in the direction. Okay, so that means in the same direction, they will attract to each other. Okay, ladies and gentlemen, please observe the slide. Example, two straight parallel cable placed 5.0 mm apart have equal current of 1 ampere, but flowing in opposite direction. Same direction attract, opposite direction, they will repel to each other. So we want to find the repulsion force. What type of force act on the cable? So since the current are in opposite direction, force of repulsion act on the cable. And what is the force per unit length? Force per unit length F over L is equal to mu naught I1 I2 over 2 pi d. Okay, so we notice that mu naught will be 4 pi times 10 to the power -7. That will be a constant. Times with the current, because 10 times 10. So 10 the power 2, or we use 10 times 10 over 2 pi. The d distance separation will be 5 times 10 the power -3 meter. So we get that the force produced between the two conductors will be 4 times 10 the power -3 Newton. Now we notice that the next slide. Okay, sorry, the same slide. So we go to the next. Thus, as a summary, when current flow in the same direction in two parallel conductors, the two conductors experience a force of attraction that pulls them closer. Okay. And next, when current flow in the opposite direction in two parallel conductors, the two conductors experience a force of repulsion that causes them to move further apart. The force acting on two long parallel conductors depends on the current in the conductor and the distance between them. Last, the force per unit length on each parallel conductor is given by F over L. Consider both of the conductor are equal length, yeah? Okay, must equal length. F over L equal to mu naught times I1 I2 over 2 pi d. Either that is the magnitude of the attractive force or magnitude of the repulsion force. Ladies and gentlemen, here comes to the end of our lessons today. Before that, same thing as the regular, we have the question for this chapter. The question for this chapter, okay, sorry, for today's lesson, okay, we have a few questions that I want you all solve it first before you check your answer. Okay, solve the question first before you check the answer. So later I will post this question in our Telegram group. So this is the question 1. Question 2. Here, question 3. Question 4. Question 5. And question 6. And finally, question number 7. That's all for today's. Thank you very much. And we continue again tomorrow.